Now that we're getting the hang of percent efficiency, let's go ahead and try something a little bit more challenging. Let's go ahead and draw ourselves a block and tackle to start with. And block and tackle isn't really what makes this one more challenging. We'll see what makes it more challenging in just a second. But let's go ahead and say it's lifting up a force resistance of, let's say, 150 pounds. Then coming out of it will be the tackle. Let's go ahead and tie a rope off on the block and then bring the rope around our tackle and then bring it back around our block down here. Let's say the force effort is, of course, pulling this down, Fe. And let's say this pulley, this block and tackle system, has a percent efficiency of, let's say, 80% efficient. And let's say, well, what is the effort force? Let's say that's what we're looking for. And so the reason why this one is more challenging is that we're working backwards. We're given the efficiency and we have to find one of our variables. And at first glance, you might think, well, this is a block and tackle, so I count the number of strands supporting FR, and what we get is an IMA. So let's go ahead and write this out. So you might notice we get an IMA of 2. And you might say, well, that's really easy. At first glance, the force effort is clearly 75 pounds, correct? Because if the IMA is 2, then we can assume that the AMA is also 2, and that means that this will be half of our force resistance. But the problem is that would be our ideal effort force. So our effort force in an ideal world, let me go ahead and pick my color coding color, that would be 75 pounds. But that doesn't really help us because we already said it's not an ideal world. We already said we lost 20% efficiency. So since it's not 100% efficient, we can assume there's no static equilibrium. Therefore, this doesn't really help us. So we're going to have to go another way to figure this out. So what we could do is we could drop in our percent efficiency equation, and we could try to work backwards from it. And we know part of this equation, so let's go ahead and rewrite it out for ourselves. We get percent efficiency equals, well, we don't know the AMA. That's kind of half the problem here. But we do know the IMA is 2. We just said it was 2. So let's go ahead and pick the correct color for our IMA. So our IMA is 2, and we also know we're multiplying it by 100. The problem is we don't know what our AMA is. But we could easily solve for it using this equation. So we can solve for our AMA, and once we know our AMA, we can find our FE because we know our FR. So let's do that. Let's solve for AMA. So what is it? Well, we could say the percent efficiency is equal to 80%, which it is. And then it becomes just a simple algebra equation. So we divide by 100 on both sides. What do we get when we type in, let's go ahead and clear this out, what happens when we type in 80 divided by 100? And you might already know this by doing it in your head, but just in case, let's go ahead and make sure we get the right answer. And we get 0.8. So we're going to go ahead and say the AMA divided by 2 is equal to 0.8. And then to solve, we just multiply by 2 on both sides. And of course, it cancels out on the left, and we get 0.8 times 2, and you might know that one in your head too, but just to be safe, let's go ahead and say 0.8 times 2 is 0.16. And so we found our AMA. We found that AMA equals 1.6. And I am sorry if I said 0.16. But then we also know that AMA equals FR over FE, so we can set this equal to FR over FE. Well, we know FR is 150 pounds. And we don't know FE. That's kind of the whole point here. But to solve, I can put 1.6 over 1 and cross multiply and divide. Or I could just do simple algebra, but I'm going to go ahead and do it this way because it's a little bit faster. And we do 1 times 150 divided by 1.6. And so we type this into our calculator. We say, well, 1 times 150 is just 150. But then we can divide that by our last answer, which is 1.6. And we get an effort force of 93.75. 93.75 pounds is our final answer. So force effort equals 93.75 pounds. And what does that mean? It means, well, we are still saving force. It's still considerably lighter than our force resistance. And we have to travel twice as far. So to lift this 1 meter, I still have to drag this 2 meters. But instead of this being 75 pounds, like in the ideal world, because of whatever we're losing our efficiency to, because of our inefficient system, we have to apply extra force than what we would ideally want.